So today, as Lee mentioned, I'm going to be talking about what we're doing with GraphQL at IBM. And so before we get started, just a little bit about who I am. I am a web developer. I've been doing it for quite a while. I'm currently working as a developer and kind of in a front-end architect role at IBM Cloud, which is Bluemix. We just did a rebrand. I'm also a former workaholic, and I'm a big advocate for that. You'll actually usually see me speaking on work-life balance, but that's for a different time. I'm also really obsessed with processes and performance, and that's a lot of what we're talking about today. And I'm 96 years old on the inside. So GraphQL is one of the most exciting things that I've seen in quite a while. Usually I look at new technology and I see what's coming up, and I'm kind of like, that's cool, but I see a lot of things that solve that same problem, so I'm not eager to jump into it. I kind of want to wait and see what happens. With GraphQL, I'm not going to go too deep into the benefits because I assume that we're probably going to hear a lot about those today. So when I saw GraphQL, I realized that it was solving a couple problems that had not been solved previously. The first one, and the one that I think is the most important, is front-end developer ergonomics. The ability to get into a front-end code base and just build something. You don't have to worry about your HTTP request layer or setting up fetch or really even understanding how any of that asynchronous stuff works. You just install the Apollo client and it just happens, which I think is a really, really big development on the front end. There are a lot of really good things on the back end too. Centralized data layers, centralized documentation, like holy crap, especially when you're looking at a company the size of IBM. I mean, I don't know how big your company is, but I'm willing to bet that documentation is bad. So scale that up times 400,000 people and you'll get an idea of what we're struggling with. So when I saw GraphQL, I wanted to get it into production immediately. I was ready to tear out our entire middle tier, replace it with GraphQL, and just like save the world, right? I was on a white horse and I was on a mission. But the problem was, I immediately met a lot of resistance. And so part of this I'm going to chalk up to the fact that like there's just a little bit of entrenchment at IBM. There's some people who've been there forever. And they just don't like change. And that's fine. But there were also a lot of really, really good questions. And I'm going to talk about those, but before I do, let me set the scene of kind of what we do at IBM Cloud and how it's built before I start talking about the specific challenges. So IBM Cloud is a node microservice architecture. We're currently set up with over 30 microservice teams. Each one of those microservices is a completely individual code base. So it's a repo with a couple shared NPM modules for things like our session management and authorization, but otherwise they're just kind of build whatever you want. This has a good upside because teams are able to control their workflow, but it also has some downsides. And one of the biggest downsides is that because we don't have a lot of centralization, things are changing in 30+ directions at once. If you look at our code base right now, it gets a little crazy, and you have problems where somebody has to get on a Slack channel and say, hey, our app just broke. We think it's this endpoint. Does anybody know who works on that so that I can ask them what's different? Because there's definitely not documentation. Front ends have to touch a lot of back ends to get data, which means that we're reaching to a lot of places, and it's hard to know, like if you're on a back end team and you need to make a breaking change, it's really difficult to know which front ends are using your stuff, which means that a lot of times the way that we fix breaking changes is we just break it and we wait for the front end teams to tell us that something broke, which is, I mean, a terrifying way to approach enterprise development, but that's kind of what we got right now. Internal documentation and architecture is inconsistent. We usually try to put Swagger docs up with any APIs that we write. Typically speaking, those Swagger docs are about 80% complete and about 99% out of date. And the code can be wildly inconsistent between microservices. If you navigate through the Bluemix or the IBM Cloud front end right now and watch your network tab, you're going to notice that you're loading Dojo, probably Dojo 1 and 2. Polymer, you're going to load Angular, probably all 5 flavors of Angular. You're going to load React. You will also load jQuery at some point in time. You might load jQuery on all the pages with Dojo. I am actually working on a microservice to rescue it right now that loads React, Polymer, Dojo, and jQuery all in the same microservice. So we have a lot of kind of Wild West approach to front end because a lot of it was built back when people thought that front end was just like a thing. Like, who cares? It's CSS. Just throw up a couple lines of color, right? So this is something, GraphQL offers some great solutions to this problem. The biggest one for me, changes get centralized. If a backend team is going to make a breaking change, they only have to let the GraphQL layer know, and GraphQL can then deprecate the right fields, add notes, give people the ability to find the upgrade documentation so that all of the teams are aware before something breaks that it will break in the future, which is not something that we can easily do now. Data access is happening through a single endpoint. I don't really need to go too deep into the details on this, but making one HTTP request is usually a lot better than making 20. Documentation is centralized and it's consistent. You can't release a GraphQL schema without making it documented in at least a rudimentary fashion. And we bundle graphical with everything that we release. So even if we don't actually write docs for it, you can go and explore and try the queries and see if they work, which is a huge step up from our current developer workflow. We also get a cleaner separation between the data and the presentation layer, which is it was something that we really struggle with because a lot of us are used to building like monolithic apps where the front end and the back end and the middle tier are all kind of part of the same code base, but it leads to leakage where things that should be happening on the back end get handled on the front end, and then when something breaks, you're not sure if it broke on the front end, in the middle tier where we actually massage the data a little bit, or if it was actually a problem on the back end, and that leads to a lot of confusion. And a lot of our back end devs getting paged at 3 o'clock in the morning because somebody did something stupid on the front end, but we didn't know how to trace it, which is something that we really want to get away with. However, when we start getting into what GraphQL can do, we run into complications. The first one is, who owns this? Like, what does this mean that every team is going to have to hand over control of their data to one single team? That seems like a non-starter. How can teams make independent changes? If there's one team managing the GraphQL microservice and a backend team wants to update their GraphQL schema, what does that mean? Do they have to submit a pull request and they're at the whim of whoever this gatekeeper is? Can one bad commit take down the whole service? If I force push to master, which we can't actually do anymore, I turned that off. But if somebody were to like re-enable that and force push to master, take down the whole service, does every single team suffer because one person made a bad choice? And beyond that, doesn't adding an extra layer actually make it harder to reconcile these problems? So we needed to find a way to get the benefits of GraphQL, but we weren't sure if we could afford the trade-offs. And so that's kind of where this journey kicked off. We needed to get some answers. And the questions that we wanted to solve were, first, could we centralize our data layer but let teams keep control of it? Second, is there a way that we could actually improve our error handling rather than keeping it at the status quo, or worse, making it more confusing? Which is what I just said. And can we make it so easy that teams actually want to switch? Can we get people excited to move over and use this service? And then the last one was, can we build a service that'll work at IBM scale? You know, we're currently serving from half a dozen data centers around the world with millions of unique visitors. Like this has got to be robust. So the first challenge that we had, can we centralize data but decentralize control of that data? And where we landed on this was the ideal solution is that each team would be able to maintain a GraphQL schema, but we wanted a way for that schema to be aggregated into a central microservice. So effectively we get the best of both worlds. But that led us to a question, which was, we're going to need some kind of a standardized format if this is going to work. We can't just let every team build whatever they want and expect that things are going to be fine. So we worked on this, and we landed on what we call data sources. I don't think that I'm originating that term. It's just kind of what we've used to encapsulate the entire thing. So your schema, your resolvers, a few other components that I'll talk about right now. So when you look at a traditional Apollo server tutorial, typically what happens is you see somebody will say, all right, so you're going to build a schema, you're going to build some resolvers, and then some stuff happens, and now you have an Apollo server. And they kind of leave the data access and all of the other like foundational bits that make that work, they kind of leave that to your imagination. So we wanted to remove the imagination from it and make it something much more clearly defined that people could realistically repeat without having to learn how GraphQL works under the hood. We wanted somebody to be able to download a template and just build something right away. So what we did was we borrowed from Jonas Helfer, who wrote an article about how to structure GraphQL servers, and we added a model and we added a connector. So the model is just what tells the data source where data comes from. In our case, we've actually optimized for REST APIs. We typically wrap REST APIs. There's some history to that. Come find me later if you want to know it. And then the connector is what tells the data source where the data is. And the model is your typical CRUD layer. It's get items by ID or set item by ID. And we wrap all of that with a common export, which makes it into a plugin. So this gives us the advantage of having each data source as an independent repo. So we get no bottlenecks. Each team is able to commit and deploy code directly to their data source with no oversight from anyone else. We have no loss of control, so the team actually owns their data. I own the GraphQL microservice, but I have no idea what teams are doing with the data on it, and I shouldn't. I shouldn't need to know that. And we get to avoid the accidental breakage problem. If somebody writes bad code and it goes into their data source, I will see that their data source has a breaking build when they move to bump the package version in the GraphQL microservice. So that means that we can see, like, hey, you've got a breaking build. You need to fix that before I can merge these changes. And that's great. Also, they can't actually, we set it up on semantic release. So if their build is breaking, they can't actually publish to the NPM repo for us to update it in the first place. So we put some checks and balances in to make sure that you would have to try really, really hard to do something stupid with this setup. So now that we've got external data sources, how do we actually combine them? So we start out, we've got our set of data sources. And the way that we approached this was we built what we're calling GRAMPS, which is I can't actually say the whole thing. It's GraphQL Apollo Microservice Pattern Server, GRAMPS. And the joke for me is that I basically think of this middleware being like, get your data off my lawn, because it lets everybody control their data, but we get to control the data source. So the GraphQL middleware here sits on top of Apollo server, and it pulls all those data sources together and composes them together. And it gives us the ability, if we wanted, where we could very easily have schema stitching in place to plug them together. And if you haven't heard about schema stitching yet, it's like my favorite new feature. And all this gives us a single GraphQL endpoint, which I am super excited about. And this was really important to us to make the implementation easy enough that you could put it on a single slide. So let's take a look. This is a usual GraphQL server. I cheated a little bit by making the text small, so I apologize if you can't read it. So in order to convert this over, basically what we've got here is we're using GraphQL Express. We're importing a schema, and we're importing a context, which we're calling myDataAccess, and plugging those into a GraphQL endpoint. So in order to use GRAMPS, we have to import the GRAMPS middleware. We then swap out the schema and the data access that are local for installed data points, packages that we're getting from NPM. We add the middleware in between Body Parser and GRAMPS Express. I haven't tested it. I don't think it matters the order. And then finally, the middleware attaches the schema and context to the request object, which I've read is bad for performance, but I'm not sure how to do it otherwise. So if somebody wants to submit a pull request, please help me. But basically what it does is it takes the GRAMPS schema and context, which are the combined output of the different data sources, and attaches them to GraphQL Express like you would normally. So this way, we don't actually need anybody to know anything about how this stuff works. They just import their data source, drop it into that data sources array, and they've got their data source deployed to our GraphQL production server. So the next challenge was, how can we overcome error handling and make it actually useful? So we looked at what actually makes an error helpful. The first thing is a clear description of what went wrong. Like obviously, you don't want an error that's like, null pointer exception. So clear description of what went wrong. Clarity about where the error occurred. So we want to know, did GraphQL have a problem? Or was it an underlying data access issue? Like did the server throw a 500? Or did GraphQL throw a 500? We need to have that clarity because I don't want the backend team to get paged because my service went down. That's a dick move. I want to make sure that the people who write the code are the ones cleaning up the code. We also want information to help with tracing bugs. So we wanted things like error codes or links to documentation, links to the model that failed, things like that. And a unique ID so that we're able to show a client-side error and then link that to, or correlate that to actual sensitive data on the server side. This was important to us. So on the client side, we came up with a model. I borrowed something that I forget the name of. It's like Apollo GraphQL errors or something, which extends Boom, which is a library for making errors, effectively. So we use this to create some custom fields. We add a description, a link to docs, which I think is probably the most important thing that we've got here, the target endpoint, so what we were trying to load, and some other things, the error code, what the status code was from the server, and then there's the GUID there. In production, obviously, we can't show all of that, so we end up, we might have our docs linked to something behind our firewall. That's pretty common. We also may not be exposing that endpoint publicly. Like, obviously, you can find it, but we don't necessarily want to just tell you, like, hey, go hammer on this endpoint and see what's there. So in production, we strip out the docs link and the target endpoint. But because we've added that common GUID, in our server logs, you can see here the GUID is, it starts with 1784. So on the server, you've got 1784. And we can just do a quick search. If the client opens a ticket and sends us the error, we can then go to the server logs, look it up, figure out what they hit and what they were trying to get, the data that they passed along with it. And this is all configurable. You can update like which things are being passed through to the client and which ones aren't. So what this means for us is that errors are going to be normalized across all data sources. Support tickets can directly reference details in the logs. So again, you send in your error message and we can go to the log and look up exactly which error you had. Errors are clear. They come with documentation. Obviously, this relies on us writing that documentation, but I'm really working on fixing that culture at IBM. And we're having good progress. Like, the teams that we've worked with have been really receptive to this, because as soon as somebody sees the power of writing well-tested, well-documented code, it's typically pretty hard for them to go back. And then the source of the given error is immediately clear. I know that the backend threw a 500, and I'm not just getting like a mystery GraphQL error. But we didn't want to like force this on anybody, so it is opt-in. So to add it, all you have to do is just grab the format error function out of the Gramps context, or the Gramps object. If you don't want it, you can use a completely different error formatting library. If you do want it, you just have to throw that in, no changes otherwise. The third thing we wanted to do was make development so easy that teams actually wanted to use it. And we knew that if we wanted teams to start using GraphQL, I needed to make the right thing the easy thing. Like, that's my mantra at IBM. I need to make the right thing the easy thing. How can I smooth the path so that the thing that I want you to do is less painful, more rewarding, more prestigious, whatever, than the thing that you were doing previously? And so all the tools that I build are built from that foundation. How can I convince developers that I'm making their life easier, not adding another pile of crap to their stack? So we went with the data source starter kit. This was the first thing. We give people a data source starter kit that effectively has all the pieces you need to deploy. You can deploy the starter kit and it will work. We also added a step-by-step tutorial that walks you through each line of code that you're going to alter in the starter kit to end up with a working data source. Right now it wraps the IMDb API, which is an open source API, which unfortunately was very unstable, I found out after I spent 3 days building it. So I've since rebuilt and we wrapped the XKCD API, which is a lot smaller, a little easier to implement, and I'll be rewriting this tutorial over the next week or so. We put the test coverage up at 100%. So you got 100% unit test coverage out of the box. And we pre-configured it to easily plug into Travis CI and CodeClimate. All you have to do is go to those places. For CodeClimate, you have to grab a test coverage reporter ID, and for Travis, you just have to turn it on. And so the code is there, but don't look at that yet because I haven't made the open source announcement. So we also built a CLI to make development easier. So we built a CLI command called Gramps. If you are working in a Gramps code base and you run Gramps -- live, it will hit live API endpoints and you will get that data. If you use -- mock, you get mock data, assuming that you've created mock resolvers. Otherwise, you just get a bunch of hello world. And we give you information about where you can go look at graphical to test your data source in your browser. The problem was, when we actually started using this in production, we ran into a snag where once the GraphQL microservice had somebody's data source in it, when they wanted to make changes, they would have 2 instances of that data source, which caused a collision and gave me a bunch of headaches. So we had to look at a way to solve that problem, and the way that we overcame that was with having a local data source override. So if you specify a data source, I'll check for a name collision and turn off the one that's installed on the Gramps server so that you're able to develop the one locally. However, to make sure that that doesn't leak into production, we add warnings. I actually add a lot of warnings because I want to make damn sure that you know that this is not production code. This is just for testing. So the last challenge that we had was we wanted to build something that would work at global scale. And fortunately for us, we didn't have to do a damn thing. The Apollo server just worked. So round of applause to those guys because they've done a great job of building excellent software that works at scale. So we were just, like, I was blown away. I put it up in production. I was like, all right, let's hammer on it. And then it just worked. And I was like, hey, yay. So this was a really kind of interesting ride for us because so I learned about GraphQL in like March or April, right? I'd heard about it, but I hadn't really done anything with it. So I built my first little toy app I think I finished it in April, got really excited about it, started working on it at IBM in May. We got it into production in July, which is a crazy tight turnaround for an enterprise level project, which we kind of did by just like not asking anybody for permission and building it, which I would highly recommend. Like, it's so much more liberating than the meetings. But then, so we went on then and realized, like after the dust settled, there were two big things that I realized, and this is where I actually saw that I had built something that maybe was bigger than I thought, because I was like, holy shit, you know what I just did? If people were to open source these data sources and put them up on NPM, then a company like, say, Universe, to use the schema stitching example, could open source their GraphQL API as a Gramps data source. And you as a developer could then build a custom app, install the Gramps data source for Universe, and write your own data source that stitches with Universe. Now you don't have to maintain a Universe wrapper. It's maintained for you, hopefully by Universe, because they'll get control over that API, but maybe by a third-party developer, maybe by you, whoever ends up doing it. But now the entire community can have access to locally built GraphQL servers that are wrapping REST API endpoints, and they will be able to like get the same benefits we get from installing Express or installing the Apollo client. When something changes, we just upgrade the version and we get the new benefits. And then the second thing we realized is after I kind of talked through that with myself, I was like, this could be really useful to people. And so we're really excited. We're releasing it under the MIT license. And we really, really hope that people are excited to use it. We're calling it Gramps, like I said. It's up on GitHub. It's up on NPM. Please go look at the docs and look at the pull requests and issues that are out there now, and get involved. You know, if this is something that you think would be useful for your company, open issues, open pull requests. Let us know what you would need. Please build data sources. Like that's going to be the thing. That if this is going to be useful for you, build a data source for your company using the Gramps format and drop it out there. There's nothing magical about the format. It's not going to prevent it from being compatible with any other GraphQL server. It's just a way that we can make these things shareable and move them on. So thank you very much for your time. I hope you enjoy the rest of the conference.